Here is an explanation for the answer to final exam question number 89 in Electronics Demystified, 2nd edition. If you have the printed book, please see page 437. We're talking about a quad antenna. In this particular question, it has one parasitic element right here and one driven element right here. The driven element is the one that we feed the signal into and take the signal out of, and the parasitic element modifies the behavior of this driven element. Now suppose that we have gain going in the direction from the parasitic element through the driven element. When we transmit, that means that we get signal gain in this direction at the expense of other directions. When we receive signals, of course, we hear signals better coming from the direction of the driven element and not so well from other directions. So here is our parasitic element. What type of an element is this when we get behavior like this? Now this diagram of a quad antenna, these are squares and we're looking at them in perspective. So in fact the planes of the squares come right out of the page at you, and the direction of gain is towards the right in the page. So here is our quad antenna, sometimes called a cubical quad, because the two square parasitic elements lie in parallel planes along a concentric axis, and if we were to connect their edges, we'd more or less get a cube if we connected all of the corners like that. That's why it's sometimes called a cubical quad antenna. Now of course these don't have to be squares. They could be round loops, they could be triangles, they could be pentagons, hexagons, anything. But generally speaking, when you have a quad antenna, most often you're going to find square loops because it's easiest to construct at shortwave frequencies in particular. Those would be between roughly 7 and 30 megahertz. A 7 megahertz cubical quad is a pretty good sized antenna because these are approximately full wavelength circumference loops here. But when we have this type of an arrangement where the gain goes from left to right, this particular parasitic element is known as a reflector. In effect, it behaves something as like a reflecting screen to produce gain going towards the right. If the gain were going in the other direction, from the driven element through the parasitic element, that is from right to left in this diagram, we would call this a director. In order to act as a reflector, when you design a cubical quad antenna like this, you should make the parasitic element about 5 to 10%, a few percent larger in circumference than the driven element. If you want to make it a director instead, you would make it a little bit smaller in circumference than the driven element. The spacing is also fairly important, and this is all described in the book, particularly under the Yagi antenna design, which operates on a similar principle to the quad antenna. But again, it is a reflector. That's how it is acting, and that, in this question, is choice A.